All right, so tomorrow, that homework sheet is due. I'll be grading it for accuracy. I'm not looking for work. I'm looking for your answers. If your answers are wrong, then it's wrong, okay? Now, tomorrow is part 1 of the test. What you will have on part 1 is naming compounds and molecular and empirical formulas. So the first thing that's on the sheet, on your homework, and the last thing that's on your sheet, okay? The naming looks almost identical to this one. The formulas are completely different, but it looks almost identical. And the empirical formulas, I think there are 5 of them. Wednesday will be everything else. Oxidation numbers, molar mass, percent composition, and molar conversions. Okay? You've already taken a test almost identical to that. So we need to sum it up, make sure you have everything completed. Before I even start attempting to teach anything, is there anything anyone has specifically that you want me to cover or to teach or to talk that you kind of have trouble with? Yes, ma'am. Okay, 15 on the back. Very good. All right. The question is, how many copper atoms, this is a good one. How many copper atoms are in 5.6 moles of Cu2O3? So what is the given? 5.6 moles of Cu2O3. And the question is what? Copper atoms. All right, so I need Cu atoms. Everybody good with that? So, but the problem is, what is the formula for the given? The formula for the given. Cu2O3. But what are they asking about specifically? How many copper atoms? So we have got to get from Cu2O3 to what? To Cu. All right. Is Cu2O3, by the way, what's the name of that? Technically, this is a bad formula. That's impossible. But it's copper 3 oxide, which is impossible to have. I don't know why that's even like that. Copper 3 oxide and copper, are they the same thing? No. Copper 3 oxide and copper are 2 totally different things. I've said this before. Some of you may or may not remember, but if you don't remember, you may want to write it down. One more time. Copper 3 oxide and copper, are they the same thing? No. What is the only way to go or to convert between or to compare 2 different things? Mole to mole. Very good. That's the only way I can compare 2 different things as a mole to mole. Now, you know how to start this. If moles is on top, where does it have to go? It's got to go to the bottom. So I have moles of Cu2O3. Now, I'm at moles. Again, what's the only way to compare 2 different things? So since I'm at moles of copper 3 oxide, can I go to moles of copper? Yes. So I can go to moles of Cu. Now, is one of these in the other? Think about it one more second. Is one of these in the other? Which one is in which? Very good. So, do you agree that if I have one of those, how many coppers would I have? 2. Very good. Does everybody see that? Again, if you're not quite sure where that came from, if I have one of these, how many Cus do I have? I've got 2 of them. It comes from right there. So that has to go in right there. Everybody okay with that? Now, let's play hypothetics for just a second. What if the question had said something about oxygen? What would it be? Everybody agree it would be 3, right? All right. Now, the problem is, can I stop here? No. Why? Very good. I'm solving for atoms. So I need to go one more step. Can I go moles to atoms? Yeah. Mole of copper to atoms of copper. All right. We should know what goes right here, right? Nothing's different than any time. When you see mole and atom, what does mole get? A 1. What's atoms get? Very good. Avogadro's number. Did anybody do this correctly? Okay. Bryce, Trevor. Very good. Anybody else do it correctly? Seth, did you do it right? Very good. You inverted them. Here's the problem with if you do it that way, when you cancel, it won't work. Okay? Because think about it. Moles and moles cancel, right? Well, if you have atoms here, how did you go from atoms to moles down here? Does that make sense? Does that make sense, though? Okay. So think about that. Everything has to cancel. The way you did it, yeah, you got the right answer, but technically it wouldn't work that way. All right, now, how many sig figs does your answer need? Needs 2 sig figs. Seth, what'd you get? Atoms of copper. Yeah, give me just 1 second. Now, before we go any further, I want to remind you of something. There are 3 things, 3, that you must always have as an answer. Number 1, the number with what? Very good, correct sig figs. Number 2, very good, the unit. And finally, number 3, the compound or the formula. Cu, copper. All right. So again, must have those 3 things always. All right. Kaylin, you said 14? Okay. Let's do 14. This time it says how many grams of SO2 are in 4.5 times 10 to the 24th molecules. So we're going from what to what? Okay, molecules to grams. So the given is 4.5. I'm just going to write cules of what? SO2. Yeah, sulfur dioxide. Very good. So molecules, if molecules is on top, where does it go? On the bottom. The problem here is, remember this little statement. Can I fly from Dothan to New York City? No. What's in the middle? Okay, of New York City. Atlanta. But what is our middle step? Moles. We got to go to moles first, right? We can't just jump. We got to go to moles first. So molecules to moles. I'm just going to keep writing. We don't want to stop there. So if moles is on top, where does it need to go? Bottom. Now can we go to grams? How many of you were so excited I gave you the masses you didn't have to solve for them? It was great, right? Made it so much faster. Now, the test is just like the last one. You remember I gave you 5 formulas, and that was the same 5 on the entire test. So once you solve for them, you'll have them the rest of the way. Okay, it's just like the last one.
Isn't there like an exception when you're looking for something that's the same? I remember you said it's something like cancels out.
You don't have we're talking about you don't have to big mold.
I get it.
Like you can just like just say
Yeah, but I don't want to teach that, and here's why. When?
on the video.
Oh, if you watched the video, I did. But not everybody watched it.
I just wrote it down.
Okay. I think you were out that day. The point is, and here's the reason why I don't like teaching that way anymore, because once we get to chapter 9, you have to go mole to mole, and I want to keep that step in the middle. I don't want to skip anything.
I'm fine with not doing it.
Okay, that's fine. All right, so moles on each side is going to get what? Ones. I gave you the mass, which was 64.06, and the molecules is?
That's 64.07.
What?
You said 6.
You said 6.
That's right. I wrote it down right. Now, again, 3 things must always be in your answer. The number with the correct sig figs, which is 2. And I know I need grams of SO2, and so the correct number is 480. Anybody dispute?
What number is this?
14. Yes, sir.
Would you count it wrong if I didn't do the mold thing?
Not here. You don't need it.
Yeah, exactly.
No.
Okay.
No. If you over the top, that over.
I did
I'm good.
that.
I'm good.
Is this test like it doesn't really matter that the answer is work?
I'm checking for work and answers on the test. Yes, it's points earned test. So you have to earn points throughout the test. Okay. Any questions? Yes, ma'am. Okay, go ahead. Give me an example. All right. Go ahead. Yeah. No. I know that. But what was the answer you got? Like in the calculator, it physically came up as 0.5. All right. All right. So this is what came up in your calculator, right? Bro, do me a favor. Shut the door, please. But the given is 79.85. So how many sig figs is this? Okay. This is 4. But your calculator only gave you how many? 1. So how can you make it 4? 1, 2, 3, and that's it. It is right. It looks weird, but it's right. Okay. No. Hang on. Stop. Okay. About the line. Remember, is the decimal point present or absent? Start on what side? Left. Go to your first row number, which is count everything. Okay. Yes, sir. I did. Okay, that's a great question. Is 6.5, sorry, yeah, 6.5, 7 times 10 to the third most. First of all, is this number larger or smaller than 1? How can you tell? It's got a 6. No. Hold on.
It's larger than 1 because all that's doing is putting some zeros behind it. That's minus 1.
How do you know it's smaller than 1? That's what I was getting at. You know that this number is larger than 1 because it's got a positive exponent. Now, so the way we can account for that is if I wanted to get rid of that thing. Now, if this Avogadro's number, you're not going to want to move that decimal 21 times, right? Okay. So, but here, I need to move it which way to keep making it larger than 1? I need to move it to the right how many times? So 1, 2, and then what's going to go in that blank space? 0. So really, you could have written that. Okay? Just to see if you're paying attention. But does it matter if you plug it in the calculator? Is it still going to give you the right answer? Sure. Somebody help him out. I don't have that. Yes. I bet you put it in your calculator wrong. One of you did. Here's what happened. If you didn't use the EE, if you did? All right, well, one of y'all redo it. You're off by a factor of 10, and normally when you're off by a factor of 10, it's you put in the exponential notation incorrectly. It's not necessarily how you wrote it down, it's how you punched it in the calculator. Okay. All right, so now, how many of you missed number 16? I had somebody in first period say they didn't even see 16. I was like, how do you not see that? It does look like it in instructions. I don't know.
I got it. I was just saying we don't know if we missed it.
All right, I tell you what. Which problem number are you talking about?
16.
Oh, we're fixing to do it. Yeah, I haven't done it yet.
You asked if we got it right.
Oh, I said, did you see it? Like, did you even recognize to do it? Somebody said they didn't even see it. They skipped it.
Yeah.
Oh, I meant him physically. Did you do it? I'm sorry. My apologies. I did say that wrong. All right. So here's the given, and this is the question. 3.45 times 10 to the 22nd molecules of SO2. And then notice what they do. They ask about grams of what? Oxygen. So here's the deal. Is SO2 and oxygen two totally different things? So what's the only way to compare them? Mole to mole. So, but I'm in molecules. Can I go straight from molecules to moles? Yes. All right, so let's do that. So I need cules, and then I need moles. Now, what's going to go with moles? Molecules. There we go. All right, now I have moles of SO2 on top, so I got to put it where? Bottom. All right, so since I'm in moles, I need to get to my O. Very good. So moles of O. Very good. Now, is one of these in the other? Let me show you where we're going for the next chapter, okay? Just for future warning. What if they say LiCl and then they ask about NaNO3? That's the question. There's your given. Are those two totally different things? They're two. So, but is one of those in the other? All right. You've all balanced equations in 8th grade. We'll need a balanced equation for this. That's chapter 9. Okay? No, I was just showing you where we're going and why the mole to mole is so important. Yeah, that's all I was doing, is showing you why mole to mole is so important, because in chapter 9 you're going to have to do it again. All right, so one of these is in the other. Which one is the one, the big one? SO2. It's the big one, right? So SO2 is the one. It's not what I needed. How many O's are in SO2? Let's play hypothetical. What if it only asked about grams of sulfur? It'd be 1. If the question asked, again, hypothetical, this was changed to moles, could you stop? Yeah, you could stop right here, but it doesn't. It asks about grams. So we got to go moles of O to grams of O. What's good news? Do you know how much oxygen weighs? Good. I didn't even give you that one. Hopefully you figured that one out. 1:16. All right. So let me just double check, make sure. I've been doing a lot of calculating in this thing. All right. So 3. So the answer I got with 3 sig figs is 0.917 grams of O. Oh, I forgot to double it. Sorry. There we go. I forgot the 2. Very good. That's my fault. 1.83. There we go. That's right. I forgot the 2. My apologies. Sorry. All right, so 1.83 grams of oxygen. Any questions? All right, now what I want to do now is, since we have time left, I want to do any of the empirical or any of the naming. I'm going to do naming, but let's do empirical since that's tomorrow. Anybody need help with empirical to molecular? Find the empirical first. Oh, yeah. Remember, they're asking you for a formula, not a number. So you've got to say, this 2 isn't my final answer. I've got it. Yeah. Yep. It is. Yep. Because you did it again. Real quick, I do want to talk about this. Number 19. It says, an analysis of a 10.15 gram sample of a compound known to contain only phosphorus and oxygen indicates a phosphorus content of 4.433. What did they leave out numerically? Okay. Kaylin, how did you get that? Perfect. That's right. So again, the total of the compound was 10.150 grams. And again, this is the total mass. And then they tell you it's made up of what? P and O. Well, if you know P is 4.433, how can you get O? You got to subtract. And Kaylin, what was it? 5 point grams. So now do you have your masses? Okay, what will you do with these two masses? Okay, convert it to moles. So let's do that. So let's see. 4.433 grams of P. Then what was it? 5.717 grams of O. That's what I have. Okay. So grams to moles. Phosphorus is 30.97. Oxygen is 16. Somebody help me with my moles. Is it fourth? 1 point. All right, so there's our moles. All right, so what we have just done, one more time, we determined the number of grams of each element. Then we converted grams to moles. That's step 2. What's step 3? The smallest one. Which one's the smallest? Okay, so 1.431, 0.1431. What is the one divided by itself? That's going to be 1. What's this one going to be? Uh-oh. What's wrong? What rule comes in effect here? Our 1-9 rule. Now listen, everybody listen for 1 second. I'm trying to say this like you need to hear it. The first number to which side of the decimal? The right side. So that one must be a 1 or a 9. It's not. So what do? Multiply it by 2. So this is times 2. This is times 2. And I know for a fact you should know this. That turns out to be 2, and that is a 5.
How would it be if it has a decimal? Then it has to be 1 9, but if it doesn't have a decimal,
You have to multiply both of them. Okay? Yes, it can be an even whole number, yes. Now, 2 and 5, that's not our answer, right? What do we want? We want a formula. Okay, P2O5, very good. P2O5. Now, real quick, let's play some hypothetics real quick. Let's say, for some reason, matter of fact, hang on 1 second, I'll do it. At the end of this chapter. After this test, so probably next week. All right, here's the deal. So what if we played some hypothetics and I told you that the formula mass of this thing was 425.82. And I said calculate the molecular formula. All right? Now, hang on. Before we go any further, we know this is the formula, correct? All right, so let me erase all this. You would keep all of it, but I just need space. All right. So if I was asked to find the molecular formula of this thing, what is our formula to get that? Nope. The mass of the MF. Very good. All right, now, where do we get the mass of the MF? It's given to you. All right, where do we get the mass of the EF? We have to solve for it. Now, what mass is given? All right, now, we have to solve for the empirical formula's mass. Please do not do this because several people have been doing this. They take that number and add it to that number and plug it in. Why is that incorrect? There are 2 of these and 5 of those. So this is what I want you to do in your calculators. Determine the mass of this thing, plug it in, divide, and then... No, I'm adding this. That was not part of your homework. And the reason I'm doing this is because I want you to see in a molecular too. Yeah, no, I'm making this up. Now, this is real. Like, it's possible, and that's why I took a second to calculate it. But it is real. So, again, solve for the mass of this thing. Plug it in. Divide. Don't say it out loud, Caitlin, please. Get your whole number, and then rewrite the molecular formula. Is it done? It's impossible because I've just made this up. Uh-huh.
I did it that quick. Much speed to balance.
No, you didn't.
Yeah. Y'all see it?
Yeah.
Y'all see it again? Y'all see it again?
No, I don't.
And then once we get that number that's supposed to be in that circle,
Yes.
we multiply times.
The 2 and the 5. Yep. The 2 of the P and the 5 of the O. All right, now what'd you do? Okay. How did you know to times it by 2? Yeah, that's all you did. What do you think is different? No. What people are doing to get this answer, they're not multiplying it by 2 and 5. They're just adding 30 and 16 and they're stopping. Because what they're forgetting is that they have the 2 and the 5 out here. They're just adding these numbers up. No. All right, so what is our bottom number down there? Very good. 141.94. When you divide that, that should give you a what? Very good. That whole number. Now again, once we get this, Keely, is that your answer? No. What do? Multiply it by what? The 2 and the... So your molecular formula is... That's right. So if I handed you a bag, and I said, in this bag, the ratio of P to O's was 2 to 5, and you reached in that bag, would this be something you could possibly pull out? Absolutely. Okay, absolutely. So again, I made this up, but it works. Any other questions? Well, let's go to the part that's probably going to kick a lot of your butts, and that's the naming compounds. We're going to talk about why that's true, though.
I saw somebody tweet set up from this position for last few years chemistry or whatever, or I would be doing well in college.
Who was that? I have no idea who that is.
No, Shay, like
Shay Williams? Really? I want to see that, for real. Because Shay gave me so much trouble. In terms of saying that she wasn't going to use anything I ever taught her. I really do want to see that. I like Shay. All right, so the purpose here, before we ever begin, we need to be able to determine if the first element is a what? Is a metal. Chris, you listen to me, bud? Good. It ain't loud. I don't want it on. You need to listen to this. So how can we know if that's not what I need? Yeah, it is. I need to minimize. I need this. Here we go. So when I have this pulled up, and you're going to have this, where are my metals? the yellow stuff. Thank you. Let's change colors. Let's change this to blue.
And the red mixed.
Now, technically, I agree with you that it's over there. However, more specifically, it's where compared to that blue line? To the left. Is there an exception? Which one? Very good. Hydrogen is the one that belongs over here. All right. So the first thing that we have to recognize in the first formula I gave you was P2O4. Is the first element to the left or the right of that line? The right. Is the second element the left or right? So both of them are the right. So both of them are what? All right, y'all are saying a bunch of good answers, but the specific thing I was looking for was a non-metal. So, Taya, you said since they're both non-metals, it's what kind of bond? Covalent. And Alec, you said since it's covalent that it must have what? Perfect. That's exactly right. So since they're both non-metals, it is covalent. And since it's covalent, they both need prefixes. Where will the prefixes come from? The subscripts. Now, don't listen to the question. What is the subscript for P? So what is the prefix? Di. Now, please remember this. Please do, and I saw this all over the place. Do not write diphosphate. Why is that not phosphate? No. Phosphate is PO4 3 negative. That is P2O4. I see no 3 negative and there is no 2 on the P. Okay? All right, so it is di, and you said what? The first one what? Keeps its name. So it is di phos. All right, let's change it over because it works a lot better on this. Di. No, the only polyatomic that has a prefix is dichromate. That's the only one, and that's because that's its name. Oh, my apologies, and dimercury, but we rarely say that one anyways.
Will you ever have one like?
I'll never give you dimercury.
No, I'm saying like. Okay, so there is carbon.
Mm-hmm.
That's what I meant. Like,
Yes.
some you keep it at,
The first one always keeps its name.
but that's
Phosphorus.
Oh, that's right.
Yep. All right, so diphosphorus. Now, the second element has a subscript of what is the prefix? Tetra. Please don't mess up the prefixes. Those are too simple to mess up. Now, Br, is it with something or by itself? Okay, so how does it end? So it's tetra bromide. Very good. Tetrabromide. All right, so that's number one. Number two, Cu. When looking at our periodic table, is it to the left or right of our step? It's the left. So it's a what when it's to the left? But be very specific. Copper is a transition metal. Now, listen to me carefully. What do transition metals have to have in their name? Roman numerals. Is there or are there exceptions? What are your three? You guys remember stuff. I'm impressed.
And then what about the third step?
Well, yeah, these three as well. So, but again, since she brought that up, let's talk about it. Please listen. Silver is always a 1 plus. Zinc and cadmium are always. And then all three of these are 3 plus. Again, I really kind of like that step in there. That really helps. No, those are transition like. Tin and lead are both 2 plus or 4 plus. Okay. To be honest with you, I have never done a chemical formula with germanium in it, ever. So I really don't know what it is. But it's actually a +4. That periodic table has them on it. Okay? So that is that. So let's go back to this. So we know copper has to have a Roman numeral. How do we achieve that? Reverse crisscross. Okay? So we need to reverse crisscross. The problem is, when I pull back, I get a 1 negative. I get a 1 positive. What must you do? Check the charge of the anion. What is an anion? Negative. So I've got to make sure That is right. So going back to this, chlorine is right here. What's its charge? -1. Very good. So was it correct? So if chlorine is right, is copper right? Yes. Let me ask you another question. When you're talking about Roman numerals, do you have to write the 1? Yes. Okay. When you're talking about Roman numerals, you have to write the 1. That's the only time you ever have to write the 1 is with a Roman numeral. All right. Finally, is Cl with something or by itself? By itself. So how will it end? Okay. Chloride. Now, number 3 and number 1 were very similar. The only difference was, what is the prefix for 5? Penta. Please don't put hepta. A lot of people like putting hepta for 5. It is penta. Yes, sir.
Can an element have more than 2 charges? Like a transition metal?
That's what all of them are. That's why they're transition. They can change.
But can they have one that 2 does?
Yeah, manganese has 4 or 5 of them.
Oh.
Yeah, manganese is 7, 6, 4, 2, and 1. So 5. The charges, how many different charges it can have. That's how it works. That's how chemistry works. If you'll go back to the very, very, very first polyatomic sheet I ever gave you, that bottom box listed the possible charges. Now, and I finally hit me this year. I'm going to give the sheet I gave y'all last, and the sheet I gave y'all this past one first. It was a lot easier. And so by the time we got finished with polyatomics, you started to remember you'll start knowing the charges of these metals when you need to know them.
That one where it was like the Davis thing and then we had like 3 parts. I already forgot that.
And that's what I'm saying. That's why I'm going to give it next year last. And again, I'm still learning and fixing things. All right, so the next one is just diphosphorus pentoxide. Now let's move on to the next one, MgPO4. Where is Mg on this thing? Group 2, right here. So, since it's in group 2, is it a metal or non-metal? Metal. But is it transition? Where are your transitions? Okay. And a little bit of the pillow. All of these right here. So since it is outside of our transition metals, does it need a Roman numeral? No, it does not need a Roman numeral. So it's magnesium. Now it doesn't need a Roman numeral. So is P alone or with something else? It's with something else, so hopefully you recognize it. What is that? Phosphate. Very good. So magnesium phosphate. All right. Next. Yes, ma'am. Yeah. Okay. AgNO3. I've already done that one. Because it's just like number 1, except it's 5 instead of 4. Okay. Get a pass. Next. Ag. Go ahead. It is silver. It's right here. Is it a metal? Well, duh. Is it transition? But does it need a Roman numeral? Very good. Make sure you know those exceptions. So it's just silver. Okay. And hopefully you recognize that NO3 is nitrate. Very good. All right. Now, this one I have a feeling a lot of people missed. Okay, let me teach it as normal. C and O. Is the first element right or left of that blue line? It's to the right. What about the second one? So both of them are to the So they're both nonmetals. So Jatiah, it's what kind of bond? Covalent. An allyl covalent bond needs prefixes. So we got to have prefixes. Does the first one always have to have a prefix? No, it does not. So when does it have to have one? No. More than. Very good. So since it's a 1, you don't need one. So just write carbon. Does the second one always have to have one? Yes. The second element always has to have a prefix. When it's a 1, what's its prefix? Okay, so it's monoxide. You breathe too much into that, and you'll die. Okay.
Mr. Richard, why doesn't the silver nitrate, why doesn't that have a Roman numeral?
But remember, silver's an exception. Silver, zinc, and cadmium are your exceptions. Okay? Silver, zinc, and cadmium are your exceptions. No. Do metals, anytime you ever see a metal, will it have a prefix? No. Yes, sir. Hang on. Is it in your box? No, it's not in your transition metal box, right? Because you know transition metals come across here. So no. Aluminum can only be a 3+.
I know that, so it wouldn't
No. Here's the reason why we don't put Roman numerals for our exceptions, Steph. Is there any reason to tell me silver 1 when I know it's always going to be a silver 1? Zinc and cadmium is always going to be a 2. Is there any reason for you to state that it's 2? No. Now, is it technically by the books illegal? No, but it's not proper chemistry. You'll read things and you'll see chemical bottles labeled. It'll say zinc 2, but there's no reason for that. Yes, sir. The only way that will work is if it's in a polyatomic, such as chromate or dichromate or arsenic. No, not arsenic. Permanganate. The polyatomics with metals in them. So, like you could have sodium permanganate or sodium dichromate. You with me? Okay. All right. All right, so let's look at a few more. I need a teacher-student moment for just a second. All I need you to do is raise your hand. Look at your sheet. How many of you feel that the left side, going from the formula to the name, is the easiest? Okay. How many of you feel the right side, going from the name to the formula, is the easiest? Okay, one more time. The left side's easiest? All right, the right side. See, that surprises me. I personally think the right side's easier. I don't know. But I don't know. Yeah, go ahead. Yeah. All right. All right. So now this first one. This is the one that may get a little tricky, but hopefully you guys can catch it. Again, let me draw my line up here. And it's C4H10. Is my first element to the right of that line? Yes, but it's the second one. No. What's wrong there? It's still a nonmetal. Remember, hydrogen is an exception here. It can act like it's over here. So will this one need prefixes? Yes, very good. Now, so for what is the prefix for 4? Tetra. Is it tetracarbide?
Carbon.
Very good. Tetracarbon. The first one always keeps its name. You can add a prefix. Be very careful here. What is the prefix for 10? Deca. Very good. Now, be very careful with this as well. This is what I do not want you to write. If the pen will write. If you have ox in your name, what better be in your formula?
Oxygen.
I see no O in that formula. People, you would be shocked at how many people do this. Okay, did you do it? Okay, good. Again, don't do that. So hydrogen is second, but is it by itself? So hydrogen turns into hydride. Very good. So carbon, deca, hydride. Now, I taught this class this. I haven't taught any of the other ones just because y'all's class is longer. You'll get a little bit extra some days. Parker, you said it. Very good. It is butane. Butane is fine, but, I mean, I get it, but nobody. How do you know it's butane? Very good. The prefix for 4 is butane. Huh? No, I gave up on acids.
That's good because acids are hard.
Bute is how you pronounce it. Because meth was 1 carbon, eth was 2 carbons, prop was 3 carbons, and bute was 4 carbons. And then it went back to pent, hex, hepta, and the rest of them. The first 4 were the only ones that were different. All right. So, the next one, lithium. Is it a metal? As soon as you see metals, what goes out the window that you cannot use? No. Ooh. No prefixes. Does this one need a Roman numeral?
No.
Where is it?
To the left.
Do group 1s and group 2s need Roman numerals? No. So it's just lithium. All right, now, again, the same thing applies here. Is it by itself? So it should end in, does it need a prefix? Will you write hydroxide? No.
Hydrate.
Not hydrate. That's wrong too.
Hydride, I said.
All right. The next one. What is Cr? Chromium. Very good. Is chromium a metal? Is it a transition metal? Yes. Now let's look. Everybody look. Chromium is right here. Is it one of our exceptions? Nope. So we need a Roman numeral. How do we get that? Okay. So the 3's got to go up here. So 3 plus. This got to go back here. So 1 negative. However, what do you have to do? Make sure it's correct. Well, first of all, what is this thing? Very good. That is hydroxide. Is hydroxide OH negative? So if that's right, then this is right. So it's chromium 3. All right. And finally, the last one. Is one of those a metal? No. Neither one of them are. So what are you going to need in your name? Prefixes. Will the first one have a prefix? It's xenon. Be very careful here. Please don't mess this up. What is the prefix for 6? Hexa. Make your X match. 6 is S-I-X. Hexa. H-E-X. Make the X's match. So xenon, hexa, what? Fluoride. All right, so let's move over to the other side.
Okay, so this test is tomorrow.
Yeah, the naming and empirical and molecular formula tomorrow. Yes. That's a good point. I probably should take the other part up. Tell you what, because of that fact, I'll do that. That way you can have something to study and look at. This is due Wednesday.
I mean, I'm done.
No, I didn't think about that. That way you can take it home and look at it and study it. Good point. Yeah, so this is due Wednesday. All right.
It didn't have to be done by today?
No, I was making sure you did it today. So when I was going over it, you would have the answers to it. Okay? All right. Has the D Bell lunch right? Lunch D? We have 10 minutes? Okay. Hurry. That's tungsten. Parker, don't say that out loud. All right, so calcium phosphate. Again, how many of you think this part's easier? I think this part's easier. I really do. Calcium. It's a metal. So what do we have to do with metals?
No, because now we got to memorize phosphate.
Well, that's true. That's a good. But I know all those by heart, so that's why I think it's a little bit easier.
Not
The other
with that
one-
If I see calcium, I know
You can recognize nitrate and phosphate and chlorate, but writing it, I can see where that would cause you. Okay, from y'all's aspect, I see it. I guess for me, it's a little bit easier. All right, so calcium is Ca. Why is it 2 plus? It's in group 2. This is where you have to know this stuff. Phosphate is PO4, 3 negative. Very good. So what do you do with those charges? Crisscross. So Ca3, PO4, 2. I could see where this is harder for y'all. I get that. All right, now, several of you messed this up for some reason, okay? Lead 4. This is the number one mistake I saw. That's the number one mistake. You were saying the Roman numeral is a subscript. This is the number 2 mistake I saw. Again, this is mistakes.
Oh, I did that.
Okay? Here's what's happening. You're forgetting that oxygen also has a charge. So this is the correct thing you should do. The Roman numeral is the what? Charge of the metal. So it's Pb4 plus. Oxygen is a 2 what? Negative. So then you have Pb2O4. How many of you put that? Just be honest. How many of you put that? Is it right? No. You have to reduce ionic compounds. So PbO2. This is correct. Okay, PbO2. But here's the thing, Kaylin, I get that, but that is wrong. If you wrote anything else but the red circle, it's wrong. Okay? So remember, reduce ionic compounds. Sulfur tetra. If you see a prefix, what do? Throw a party. Write what you see. Okay? How many sulfurs? How many fluorides? All right, very simple stuff. If you see a prefix, throw a party. The prefix party, I like that. Strontium hydroxide. So strontium is a metal. So what do? Guys, y'all listen, please. Okay. Now, Sr, what group? So it's a, be very careful here. Very good. Now listen, hydroxide, OH negative. What do you do with your charges? Is this correct?
No. I know what you're doing.
That is right. This is wrong. What was I going to write, Kaylin?
You're going to write SR, SR, parentheses, OH2. No.
I've just wrote that.
I meant, yes.
That's what you, yeah, right.
I said that.
Why is that incorrect? You've got to have parentheses. The only time that you do not have to have parentheses is when? When that number right here is a 1. The number after the polyatomic.
Can you circle it to make it so I can tell what you mean?
It's the pen. That right there. All right. The next one. See prefixes, throw prefix party. Just write what you see. Nitrogen is N2. Dioxide is O2. Please make a very emphatic point here. How many of you, just be honest, wrote no? Why is it not NO? If I change it to the blue, NO, is it the same name?
Nope.
Not anymore. That's what?
Nitrogen oxide. Monoxide.
Nitrogen monoxide. You can't change prefixes. They're locked into place. All right, copper 1 sulfate. Copper is a Cu what? Exactly. If you reduce it, you wouldn't have a party. Very good point. All right, so sulfate is what?
Can we have a prefix party?
Yeah, at home. Yeah, studying tonight, you can have a prefix party. All right, so when you do it, you should get Cu2SO4. All right, 4 more. Formos. Now, I want to do this before the bell rings, just in case. Please listen. Number one, prefixes, real simple, right? What is that? Perfect. This one. This is the one that people are going to get. Before you begin, please don't mess up these symbols for this. This is not MG. The easy way to tell is the N comes before the G. So it's MN. Another thing, don't blow the Roman numerals. What is that? That is 6. The next thing, this was what I saw the most of. I saw MN70, MN60, MN06. None of those are right. Again, my bad. All the O's are N's. Sorry.
So it's MN06?
It was MNN. So remember, it's N, but what does N have? Sit down. Why is it? They have a charge. Okay, so we have MN3N6, which is what? Is that right? Please, guys, please stop. Is that right? Why? That is correct. Reduce ionic. All right, guys, good luck. Study tonight.